And it says we're live, so we're live. JP, how are you?
Hello, y'all.
Steve, good to see you.
Hey, Mike, how's it going?
Good. So today's guest is Steve Hicks, and we'll get to that. We've got some guests in the room as well. We got another Mike. So from St. Thomas, and I even know where that is. That's in Ontario. It's pretty close to Detroit. It's getting over there, but he's first on the list. We got a couple of Canadians. Rick and John and Mocha. Yes, we talked about Mocha the other day. Arnie, I guess you like that. I had a friend tell me about Mocha. Do you know about Mocha, Steve? The for IP over RG6 75 home code. It's a modem to modem box. You just put it in your house, and you can actually wire it into a sort of an RF cloud. Put a bunch of these boxes all over the place where you maybe can't draw Cat5, but you could draw a 1 gig, 10 base 2 line is essentially what it is, but you get the idea. It's you can run it quite a way. There's my buddy Andy, who I got to talk to him this week. And now we're getting into some DX.
It's like BPL, except they actually put it in coax so it doesn't radiate this time,
Yeah. Mm-hmm. Yeah, and you can haul it quite a distance. Hey, Ned. And, okay, I said I wouldn't say anything, but it's too funny not to. So, JP's, we're talking about, like, we just don't work 9 to 5 these places. We're always engaged in how he was having a problem falling asleep, so he was watching my video on networking.
Yes, 11 p.m., and I was listening to you and Dan. Yep.
So, in case you missed it, Dan and I, in all seriousness, did a video on really basic networking. And the other day, let's see, AW. We'll call you I don't know what your first name is. Hey, Max, there's more DX. And so if you haven't seen that and you want to know what a modem and a switch and a router is, and we explain it, so I'm sure you've heard all these terms, and they go, yeah, your firewall's doing whatever. This might help you out. And so we have that there. And Steven, that's awesome. I think it'll be a good purchase. Hopefully, it might be your last radio too for a while. We really want to make sure they're somewhat future proof, so we have new stuff coming with them as well. Hey JP, so what do you got today? What's going on? Did you freeze? Oh, there he is.
No, I'm here. I was typing something. So
he's answering a sales call.
Yeah. Yes. Yeah, we shipped the current production batch for PGXLs, so a lot of people got their amplifiers this week, and we're waiting for the next run in a cup to be ready in the next couple of weeks. So anybody that is looking forward to get an amplifier, they can reach out to me, and probably they're gonna be shipped in the next production batch is gonna be ready in 4 to 5 weeks, more or less. So by pre-ordering the amplifier,
okay,
they can secure it.
Yeah.
So.
And the other big question we have, of course, Maestros are a little long waiting for things and parts and stuff. So believe me, it's the minute we can get them out the door, we want them out the door. So, but no firm date yet. So good.
I'm still waiting for mine. I don't have a Maestro here. I'm in line for one.
You don't have a Maestro?
I don't have a Maestro. Nope.
Maybe. Well, Steve's got to move, so maybe he can find you a spare one.
There you go. No, I think I gave mine up for a trade show or something here 6 months ago, and haven't seen it since. Maybe a year ago.
Oh yeah, well I know the person that took it, and she might have sold it. So.
Yeah.
You know the term pre-loved, Steve? Doesn't ring a bell.
No.
Alrighty, so we'll get going. So today I invited Steve Hicks as our Chief Technical Officer for FlexRadio. And Steve, of course, you've been around since the kitchen table, right? And
after that, but close
to the kitchen table original design story that Gerald tells. And I really wanted Steve to take us through what got, I guess sort of the migration or the thought process as the 1500s out there, the 3000s out there, the 5000s, all actually an amazing success considering, the time frame and everything. And so what brought us to today? Oh, there's another question first. I always ask everybody a little bit of their early ham radio life. Usually what got you into ham radio, or what some unique part of it, including being the odd storm chaser, or what were you, a UFO chaser?
Yeah. Well, I kind of started out, my dad's a ham, his call's W5TX. And I used to, when I was a teenager, go to sleep in my room, and I had a stereo in the room. And when Dad would work sideband, he had a kilowatt amplifier, and I would fall asleep to, being recorded in my stereo. So that kind of got me started. But I don't know, I got my license at 12 and got upgraded to extra when I was in college, and, kind of basic amateur stuff. You asked about UFO chasing. It's kind of a funny story. We were talking about this earlier, and I like to do microwave roving a lot. And Jim Reese, WD5IYT, who's the Silent Key now, was my roving partner for most of that time. And I would rove with Greg Jurens, W0GJ, and Joe Jarrett, K5FOG. And we were out, there's a grid confluence out in West Texas. And we were out there doing our normal roving deal. And somebody had spotted a UFO in West Texas probably a month or two before. And so we're driving through with these rigs that have antennas and everything all over them. And we pulled over somewhere, and this lady comes running up to us. And no question, she knows already that we're there to spot the UFO and find out how it got there and interrogate the aliens and everything. And so she's asking a bunch of questions about all that. And, we're trying to figure out what she's talking about. And we finally realize what it is. And I'm kind of busy trying to work somebody on the air. And so I give her this kind of pat answer about, no, we're amateurs. We're federally licensed or something. And it became a big joke. And Greg always teases me that I go out and say, we're federally licensed,
Talking about UFOs, check the cool QSL card that I got today.
Hey, that's very nice.
Oh, that's awesome.
Yeah.
It's very War of the Worlds looking.
Yeah.
And by the way, if you're hearing some banging, we know exactly what it is. So please just tolerate it.
I'm having carpet put on my stairs,
so and everybody, of course, is COVID at home at the moment. So cool. Well, thank you for sharing that. And you've also built a couple of, your contributions to the microwave community are pretty interesting. There's a lot of things you've created over the years, from, I guess, was the Apollo board and et cetera, that were very key for microwavers for stability
Yeah, one of the things, when I first started roving, I was buying transverters from Down East Microwave, and they were crystal controlled, and I would go rove in the January contest, and the January contest is freezing cold, and I had this stuff over in the back of a Avalanche, which is like a pickup truck, and so we would key down and it'd get warm in there, and the things would drift in one direction, then you'd stop talking, it'd drift in the other direction as it got cold again. And so I really wanted a way to lock them on frequency. So that was what the Apollo was all about, was trying to get them locked with GPS.
Yeah, and they're still in use today, because I have a couple of friends even using them. So that's great. So tell us this little part of the Flex story, if you can.
About how the 6000 got started?
Yeah.
Well, so I was at a Central States VHF conference, actually presenting the Apollo. And this guy comes up to me after I talked about the Apollo. And he says, listen, I've bid on this, or I'm talking to the government about building this radio for them that does these various things. And he kind of described it. He said he wanted to know if I'd like to come work for him and help him design this radio. And I said, look, I'm a software guy. You've confused me with a hardware guy, and I don't really know much about that. It's not really my thing. And I said, I'll give you some names. So I gave this guy some names. His name is Gerald Youngblood, K5SR. And nice guy. And so, I don't know, I was working somewhere else at the time. And the more I got thinking about it, I thought, I probably ought to talk to this guy. Sounds like a fun job. I'd never worked in ham radio and all that kind of stuff. So I came down and talked to him some, and we hit it off, and sounded like a really fun thing to do. So I agreed to help him build this piece of equipment, which we sold to the government. But it was a really interesting deal where at the time, the government and the people that were in the radio industry believed that the best dynamic range, the best radio could be built as a narrowband radio that was either direct conversion or super heterodyne or something like that. And so what the government wanted us to build was a combination of a receiver like that for very good dynamic range, but also another receiver that we could look around a wide portion of the spectrum and locate people that were interesting that we wanted to listen to. And so the net of the project was, the assumption was that receiver, which had to be wide banded, would not be as good as the other receiver. And so Gerald got to work on all that and looking at it, and figured out that as we built that radio, that it actually outperformed the narrowband radio. So my job on the project was to build the computer control and several of the boards for the radio and the backplane, a bunch of other stuff like that. So at the conclusion of that project, we both had this epiphany that we could build a better radio using direct sampling technology. And at the time, there were some other experimenters doing work in this area, which is the HPSDR group. And so our software was all driven around the idea that we had a not very much horsepower in the radios, and the radios just spit samples off the air from a direct conversion receiver. That's what all the 1500, 3000, 5000, all those radios did. And so as we started talking about it, I said, we've had trouble with various communication technologies. We did FireWire and USB, and each of those has drawbacks that we didn't like. And we were really concerned about the adoption of FireWire, that it was on the way out, we felt like. And at the time, Ethernet looked like it was going to be ubiquitous. Everybody was using it for everything. And so we said we want to build a radio off of Ethernet, and wanted to put processing power in the radio, because we had had issues with when you run a computer and a radio together as a system. Anything that you do to that computer can cause you issues on the air. So like if you ran any virus software and it decided to run right when you're transmitting, it might cause you a problem. You might have radio dropouts or something. And we worked really hard to fix a lot of those things in the 5000 era, and had good success doing it, but decided that for the long term, that's not what we wanted to do. So we kind of got this idea of this Ethernet controlled and run radio that had its own horsepower in it, and it was a wideband radio. And so once that became clear that we could build that, then it was all about, well, what could we do with that? And we thought, well, we could put multiple receivers in there. We could put pan adapter, spectrum survey machines. And so we started designing the architecture and all that around it. But one of the other things that happened was our software was all open source at the time. And we were having a lot of trouble because there were very few people that the idea of the open source software was that we would have contributions and everyone in the community would contribute. And so we would be able to achieve much better software quicker with all these people giving us stuff. And we did have some really great contributions. But in terms of actual lines of source code, it was a very small portion, less than 5% of the work was done by volunteers. And the flip side of that was when we would think of a new idea, like one of them was tracking notch filter. When we created the tracking notch filter, we began checking that code in, and it was very clear from the code what we were doing. And so we would have other people that were releasing their own radios that had similar kinds of hardware that would beat us to the punch. So we would invest all this money creating the technology, and somebody else would jump out and say, hey, I've got this new thing. And so while we were testing it and making sure it worked alongside. So this is the other deal we decided, is that we wanted to move to closed source software and invest very heavily in that software. So that's kind of how we got started off.
Wow. Yeah. And the you know what? I don't know. I've talked to you in a while because you guys have been on your project, but the tracking notch filter, which is an amazing tool, if you use it on a satellite system when you're dealing with Doppler, and I've got a local birdie in my house, it's the cat's meow. I notch it out on 2 meters as I drift by, and it just keeps staying notched out. And it was cool before, but I could put up with it. But on the satellite, where I had like 3 of them, well, okay, this one, all gone. Okay, he sounds a little thin, but I can still hear beautifully what he's saying right down into the noise. And so that's amazing as well.
Yeah, you never know as an engineer whether the stuff that you dream up is going to be really cool, or people are going to go, yeah, that's not a big deal. But everybody really seemed to like tracking notch, so we're very pleased with that. Yeah,
and you never know how they're actually going to use it either, right? That's in any software product. You develop it like this, and they go, well, I never thought you were going to do that with it.
Yeah.
So and that's how we led into the 6000 world then.
Yeah. So because we started over from scratch on the hardware and the software, there was a lot of work to try and make all that stuff work. And we got to the first date and where we announced it, and we did a really big campaign around that and pre-sold a bunch of the radios. And you can't imagine the glue that we had that pieced all that stuff together to make the demo work. But we had a really good demo of what we were working on. And lots of work, but after that, between then and when we actually released the radio, there was just incredible amounts of work from everybody on our team. We had a small engineering team at that time. It was Eric and myself, Eric Waxman, KE5DTO, and myself were doing most of the hardware work. And so we decided the office was too distracting. And so we came and worked out of my home lab. So I've got in the current house I'm in now, I have a third floor that has a lab in it. And he came over and every morning he would drive to my house, we'd work in the house and do that. He'd drive home. And then when we started working on the DSP pieces, Bob McGuire, N4HY, who had helped us a lot in the 5,000 days, came and stayed with us. And so that was a really great time. It wore us all out. I mean, we would literally get up, eat breakfast, go upstairs and work until we couldn't stay awake anymore and then go sleep. But it was fun.
That's not an uncommon comment for anybody in, in a garage development industry, right? That's normal, to be expected, right? It's, and fortunately you've got some funds that drive it, and sometimes you don't. And
we, when we started down that path, we had an advisor that was or somebody that we talked to about it, that was a venture capitalist, and told us that we really shouldn't do this, that if we switched everything, the hardware and the software, we'd lose the company and we'd go under. And it was very wise advice. And so we considered it quite a bit. And there was a point where Gerald came and asked Eric and I and said, look, if we do this, are you guys sure you can do it? It was a very gut up moment where you're like, yeah. So we decided we'd go do that. And so there was a little bit of, or a lot of, we have to prove, that we can do this, because, this is Gerald's company. We don't want to, do something terrible and drive the company in the ground. So we worked really hard to make it happen.
And Gerald's, how do I word this cautiously? He's a very not timid, but he's very soft spoken, I guess is the word, right? And so it's not like he comes in, wielding a stick and say, can we do this? It's, what do you think? And,
it's funny, before I came to work for the company, I had seen the SDR 1000, which is of course a couple circuit boards, and is essentially an amateur hobby project that you'd see anywhere. And I ran into him at an Austin Summerfest before I ever talked to him about working for Flex. And he was there showing off the 5000. I can remember seeing the radio the first time and thinking about what it took to go from those boards into a production radio that had a metal chassis and heat sinks and everything well thought out, connections on, everything that was done, commercial software and stuff. And I remember thinking how impressed I was that he had gone from a few stacks, a few pieces of circuit board that were kind of sitting around into something that was a real product in one jump. And so, you might say Gerald's not a really risky person, doesn't like taking big risks, but at the same time, you can look at that and say, that's a big jump and it's a big risk. So it was really impressive. And so that was one of the things when I joined the company that I remembered and thought a lot about.
Amazing confidence he has in his people and his team too, because you can't do that alone. And,
that's right.
It was awesome. So let's go on to the radio a little bit, if you don't mind. And we haven't talked about this ahead of time, but the radio, JP and I spend our lives explaining to people what a spectral capture unit is, and I usually do it in a sentence saying, we take all this ether and we spit numbers at the back end, and there's a lot of horsepower in that.
Yeah. So when we thought about the architecture of the radio and first designed it, one of the things that became clear in a wideband world is that the concept of a receiver it's redundant and doesn't really mean anything anymore, because we're so used to thinking about a receiver chain being, you go from the antenna spigot through a series of mixers and amplifiers and then come out with something that ends up as audio on the end. And in the wideband world, you can sample the entire HF spectrum, and then out of that, you could pull multiple receivers or spectrum displays or all kinds of things. And so we kind of hated to call that thing a receiver. And so we tossed around different ideas about what we could call it. And so that's what we ended up calling it, as a spectral capture unit. And then we say within that, you can place individual receivers. And one of the great things that we got out of that technology capability was the fact that because it's all in kind of software, because it runs in an FPGA, and it's just mathematics and numbers, each receiver that you create is just as good as the last one. Whereas if you went out at that time, if you went out and bought an off-the-shelf radio that had a second receiver, you had to look at that performance of the second receiver and decide, was it as good as your first one? How good did you need it to be? And all that kind of stuff. And if you got two that were equally performing, that radio was really expensive. They were the $10,000, $15,000 class radios. And if you got one that had a second receiver that wasn't quite as good, but would function as a second receiver, those were more in the $3,000, $4,000, $5,000, $6,000 range. But here we could get as many receivers as we really wanted to get out of it.
Right. And the FT1000D came out, and then it had the sub receiver. You gave up a lot, but you had a sub receiver. At least you had something, but it wasn't in the same league. And it's still a reasonable, very good radio in today's superhet world. But now, as you say, we have all this data it's all the same. You go, here you go, you can have one, you can have one, you can have one. And we start to see that, and we routinely even get questions going, what's this spur? People have birdies they never knew they had. They've got this amazing piece of test equipment we happen to call a ham radio, right? That can see, what did you told me the number. It's about 4 pixels per hertz, or 4 hertz per pixel.
Well, you can get zoomed on a 6600, 6700 is 1 pixel is 1.57 hertz.
1.57,
Wow.
okay. Now, JP, I don't know if you know this number. So all that data comes out of the spectral capture unit, and then it goes into the FPGA, right? And the data rate was the equivalent of 300
4.7 gigahertz or gigabits per second, something like that.
And it was something like 400 or 300 Raspberry Pis running in parallel.
Oh yeah, it's a lot of performance.
It was. I did write it down because we did work out that math one day. But and this is what makes this radio so different. And because of the vision, you guys and Gerald and whatever, and I've sort of sat on the edge and seen some of your brainstorming sessions, and this is what. You get so many ideas, and we get so many ideas, and we had thousands of ideas before, and they're all great ideas that people come forward with, but everything has a trade-off. And this is what I remember you telling me at Dayton, this going, that's an awesome idea. Did you think about this type of operator and how that would impact them? And I went, no, that's not going to work. But, so if you're listening and you've ever come forward with a thought, then it may not have played correctly. It's because there's a much bigger picture that we can't always accommodate. So
this is kind of one of the frustrating things about the hobby, is because it's so diverse. You have guys that are doing CW contesting, you have guys that are trying to work satellites, and guys that are bouncing signals off the moon, and whatever all they're doing. You really want to, because somebody, you know how it is. You have such a love for this hobby and what it's brought you. You want to honor all of those people and give them all what they need, but then you also have the marketing sales responsibility, making sure that you do things for the majority of your customers and all that. So we have done a lot of things that are kind of for niche markets, and we pride ourselves on doing that. But you always want to be able to do more. Yeah,
and it has to be able to sell radios. To be blunt, when your chief financial officer says, "Okay, is this going to make you more? You're going to sell more because of this?" You sort of have to have a story to go with it, and it's a fair question to ask in any company, right? I'm not going to. And there's been many amazing products developed around the world that haven't made it more than Sony was famous for it, shipping stuff that made it one version.
The design of the radio was a really interesting journey too, because none of us had ever built a wideband radio before, so we did a lot of learning along the way. And one of the things that was really interesting for us as radios and engineered guys is the performance difference in the radio. In the superhet world, we have all these tests that the ARL will run and put up charts in the magazine that show the performance. And we found some really interesting things about the difference in superhet and wideband radios. So, in a superhet radio, when you put 2 tones into the receiver, you get IMD, and we can watch how that works. And then there's a point where those 2 tones, you're raising them in amplitude. All of a sudden, the IMD shoots up out of the noise floor and grows at 3 times the rate of the 2 tones that are going up. And that's a point that we all look at as a performance number in superhet radios. And so when we went to build this radio and we ran the same kind of performance tests on them, the radio behaved very differently. And so we had to talk about that in the community. So we spent time talking to ARL and others about those performance characteristics and how to measure the radio better. But one of the funny things about it that's really interesting that probably most people don't know is that if you take a normal superhet radio and put it on the air, the more signals that you have in it, the worse it's going to perform, because it creates spurs in the noise floor and IMD and all kinds of other stuff. And it's actually bad for it. So a superhet radio performs better in the lab and worse on the air, just as a generalization. In a wideband radio, because you're doing digitization of the signals, as they cross certain points in the A to D converter, if they cross at the same points repeatedly, that will produce spurs. And so the net of that is, with just a single signal in or 2 signals or something in a wideband radio, they don't perform as well as they do when they're on the air. So it was really funny, because when we first started, the performance numbers didn't initially look as good because of some characteristics like this, but the radio actually performed much better on the air than it did in the lab.
Mm-hmm.
So eventually we figured out how to make all that stuff work better, but really fascinating stuff.
Yeah, that was something that Tim spent a lot of time explaining this because he knows it fairly well too. But I was really amazed that, and of course, what we do in a software-defined radio, and as I say, don't get the software part wrapped around your head if you're looking, because that's just a technology. It's just the bits that are happening between the antenna and the speaker. We've gone from tubes to semiconductors to surface mount, and now it's just then we'll just get into quantum mechanics, right? That'll be the next phase.
Mm-hmm.
Yeah, absolutely right.
So, well, Steve, that's anything else you want to add today? I know we dragged you away from your team and some very entertaining dad jokes from our previous meeting.
I don't know about anything, or we can finish up whatever you want to do, Mike.
That's good. Let me think. What else can we talk about? The one thing the radio does that I saw immediately is because I was one of those consumers that would walk up to Steve, long before I ever started here. And sadly, he knew me by name, and that was both good and bad. And was probably one of those customers, but at least I just sit there because I came from a software engineering background, so I sort of knew your life a little bit. And you pulled out when I first saw the 6300 and saw the LAN connector on the back, and I'd asked him this, and I'm sure he doesn't remember. I said, "What can I do with that connector?" And he goes, "Just about anything. Maybe not yet, but just about anything." And that's coming. And we've come. If you back up to 2013 and come forward to today, we've accelerated the remote operating, or the ability to write a program to go with the radio that does what you want it to do, and you don't have to be a seriously in-depth programmer. Heck, I was able to do stuff, and I know nothing about coding. With what I've learned with Node-RED, it just works for me. And my hat's off to you and your engineering team, and Gerald and Eric and Abed and Ed, et cetera, that have opened that door, because like Steve has gotten this question many times. When are you going to write an Android client? And the short reply is the door is open. We'll give you guidance to get there, right? And
so the deal on the Android and Apple clients, for iOS or Mac OS or whatever, when we first started talking about that, when the radio was conceived, we did say you're going to be able to run clients on all these different devices. So we told people from the get-go there would be these things come along the path as we move forward. We went and did an evaluation of the business case to go build an iOS app, and we looked at it and decided that for us it would be very hard to do, because once you build something like that, you need to keep that. Typically, would want to keep that engineer on staff, and care and feeding of the engineer, and what else you're going to do with them, since we didn't have other products for iOS. We decided for us it really wasn't a great financial proposition, but at the same time, we really felt like it was a need for the customers. And we know hams, and we know they're innovative and always interested in doing things, and come from all different realms of the technical world is in society at large. So what we did was decide to put an API forward, and I don't know how many years ago this was. This may be 2012 or 13 or something like that. So we created the API and then encouraged people. And when people would come up and say, "Hey, I'm an iOS developer. When are you going to have an iOS client?" I'd say, "I want to talk to you." Conversations. And so we've had them with numerous people, both on iOS and Android. And Marcus in Germany, who's written the iOS client, kind of did that on his own. He asked us a few questions about it. He's a very talented software engineer, and created that and then showed it to us. And we went, "Wow, this is amazing. We would love to have this as part of our product lineup." And so we talked to Marcus about that. And so Marcus takes all the revenue off of that product, and it's a great complement to our product. And so we've tried to do the same thing on the Android side. And I've talked to a couple of different people over time about doing that. Just none of them have gelled. And I think part of it may be that in the iOS world, it's perfectly acceptable to charge for an application, because it takes a lot of time to invest in that. I don't know how many hours Marcus has invested in it, but a lot. And so he was able to take that and sell it in the App Store. In the Linux world, in the Android world, I don't know how well that works, or whether they'd be able to sell it for the same money. Certainly in the Linux world, there's more of a no software should be free kind of mentality. And so the incentive isn't there as much for those guys. But certainly if there's anybody listening today, or anybody wants to work on an Android client, we'd love to work with you and help you do that. The API is very easy to use, and most of the heavy lifting that's done is done inside the radio. So the client is pretty much a control and presentation device. So there's a couple of questions that have come in. Can we?
Yeah, I'll come to those in a minute. But you could make an Android client or whatever. Just ignore the pan adapter and the waterfall if you wanted to, right? So you could just handle the VFO and the audio and a push to talk line. You'd be done.
That's absolutely right. It is a what we call in the software world a publish subscribe style of API. So if you don't want the pan adapter, you just don't start it and don't subscribe to that data, and you could do all the other stuff. But the pan adapter is really not hard to handle.
Okay, so we have a couple questions here. Which one do you want? You can see them, so tell me which one you want to see.
So let's see. There was one here about bandwidth from Michael Lukasic, it looks like, about the bandwidth of the pan adapter. And so he says, if the 6400 has only one SCU at 7 megahertz bandwidth, why can't we have 4 1 megahertz pan adapters? Well, certainly anything like that's possible. We could go do that. It really came down to what we felt like would be most beneficial for the customers. And we felt like with being able to see 7 megahertz, you could see with a couple of pan adapters. Of course, on a 64, you can see 2 at once. On one antenna, you could see 14 megahertz of bandwidth. And it gives you a lot of awareness of what's going on in the spectrum. We could have made other trade-offs and do that as more smaller ones. I guess part of the reason we ended up there is because the resources that we had in the FPGA when we built the 6700, we wanted to do 8 receivers in it. And it was kind of there's nothing magical about 8. It was really look at what's possible. And we thought if we opened up 8 receivers, new applications would be created to use those sort of things. So we knew there were no applications at the start to do that. And so at that time, we looked at it and looked at what the capabilities were. And we realized that 14 megahertz was about where we were going to end up on the pan adapter. So then when we built a more entry-level radio, we sized down the FPGA. We looked at what fit in there and wanting to give people as much bandwidth as we could. We ended up at 7. So we ended up with a couple of 7 megahertz pan adapters instead of 4, 3 megahertz or whatever else. That's just where we ended up.
Right, and that doesn't prevent you from being at 160 meters on one pan adapter and 6 on the other if you wanted to.
Right.
Okay, so So the next question you wanted to.
Let's see. There was a question here about APD. Are we going to see APD in the 6000? We continue to work on that. It's a active R&D project we have. We've had great success on that in the last year, and we'll see where it goes. We haven't yet productized that, so it's something we continue to work on. I think we're a lot closer than we were a year or two ago. So we'll see.
So this is adaptive pre-distortion.
Yeah,
and it's about it mates with the amplifier you're using, and et cetera. So
yeah, the idea is if you look at what's happened on the receive side, there's been a lot of focus on creating better and better receivers, but the transmitters haven't really gotten any attention over the years. And so this is a focus on the transmitter to create a cleaner transmitter. And that's really what this is all about. And the real concept, what APD really means is that when you transmit through power transistors, they're very linear, but they're not completely linear, and they have some nonlinearities in them. And a nonlinearity means that if you give it a certain input signal, you want a certain output signal that's maybe 10 or 20 times that. When you give it a stronger signal, you want the same multiplier, but that gain changes over the transistor's range. And when that changes, it creates spurs and stuff in the output of the radio. So even though it's very, very clean, it could be cleaner. And adaptive pre-distortion looks and characterizes those changes in the transistors and then automatically feeds that back into the signal given to the transmitter to push it a little more or change what we send the transistors so that what comes out is exactly what we want to come out. So you essentially distort the signal before you put them into the transmitter so that they come out clean.
Wow, that coupled with controlled envelope single sideband, we'd have a killer signal.
Yep, absolutely.
And one of my favorite things.
About the number of coding hours in Smart SDR.
Yeah.
So I can't tell you exactly. We computed at one point the total dollar investment, and it was several $1 million. So I don't know exactly how many coding hours, but if you think about it, we started in 2011, maybe 2010 coding on Smart SDR, and we started with 2 guys and pretty quickly ramped up to 4. And all those people have been working on Smart SDR from then until now. But our team is substantially bigger now. Our software team is I don't know, it's closer to 10 people now. So I don't know, you could kind of draw a line there and calculate how much it is, but it's a lot of hours.
2011, I was in high school by that time.
No, you weren't.
And every line of code though, so you say you write some features, you fix something, then you have to go through code review, which is, I don't know what people understand, that it's not just hey, I wrote my code and I checked it in and let's compile it and ready to go, right? There's a whole checkoff process.
Yeah, we've developed a really great culture around software, which I'm very, very proud of. We started out for several years. We had 4 guys on our software team. We had myself, Eric, Ed, and Abid, and the 4 of us worked on software together. And we kind of got this mentality where when we go look at each other's code and talk about what we're going to do, we close ourselves in a room and we talk about each other's code in a way that is very matter of fact about the code, but not insulting. So, somebody would tell me, your code looks like crap. Why did you write it that way? And I'm supposed to not take that as an insult and say, wow, any given day I could be a bad coder. And I can't remember which guy it was. I think it was the guy that runs the software outfit that did Doom, the game, said essentially that on any given day, any one of software developers could be brilliant or an idiot. Mm-hmm. And we all know that to be true, people that write software. And so we feel very comfortable going in the room and saying, yeah, I wouldn't have done it that way. We should do it this way. And then we have a conversation about, is it worth redoing, or what else are you going to do? Or are you going to go ahead and use that code? So that's really persisted through time. And it results in every single line of code that gets written in our radio gets reviewed by multiple people. We have one senior developer and potentially other junior developers review that code before it makes it in. And if there are issues with it, which I would say, if I had Ed here, he'd tell me exactly probably, but there's probably 80 or 90% of the what we call pull requests, which are code changes, have some sort of changes that are recommended to them that get made before that code goes back into the code base. So
we'll have to get Ed on here and ask him.
Yeah, there you go.
We'll see how that goes. And then, and this just brings up, your style too. You're a big fan of education and mentoring, whether it's in work or even the hobby as well. And, I'm trying the same here. I've taken your lead on it, but because our average age is generally getting older, and I see so many forums and stuff. And I, part of what I do here is watch what's going on everywhere else too. And you want to push my button and say, look it up in the manual. Now, I might say, look it up in the manual, but they give you the page and paragraph, or I'll copy the paragraph in. But I tend to, my answers, and you can call me out of it if I do it wrong, try to at least give some background to it. You may want to consider going this path as a softer version of looking it up. But because, we've done some great manuals and they're written in English and there's some good data there and there's changes. But are you getting a chance to do any other mentoring with everything else going on? I know we've had some students and stuff.
Yeah, we had, we're working on a big government contract right now, which we won here last year. And we're about through with the hardware development side on that. We've been working on the software quite a bit. And while that was going on, I stopped doing some college mentoring. But for the last, 7 years or so, every semester I take on a new group of college students. And I take on electrical engineers. I get a group of typically 3, sometimes 4 people. And they're in their senior design class. So they've had 3-4 years of schooling. And what they're being asked to do is come up with some kind of a project and do that and be able to present to the employers that they're interviewing with what they've done and what they've learned. And it's really kind of interesting. I don't know what it's like in other countries. I know we have folks on here that are not from the US, but in the US, a typical thing to do would be to teach all the students all of the mathematics and details about how capacitors and inductors and all that stuff work and digital electronics, but they really don't get as much hands-on probably as they should. They'll work with demo boards and stuff like that. So my deal is whenever I take on a group of students, I make them create a circuit from scratch. They have to do a schematic capture on it, turn it into a circuit board layout. I'd say 80 or 90% of those I require to have some sort of a processor on the board and write some software in it, and then do board bring up. They have to actually make the board. I usually have them send out and have the PC board made, but then they'll get a stencil and actually apply solder paste to the board and stick the components on with tweezers and then put it in a reflow oven. And then when the board comes out, they have to test it and verify if they soldered anything wrong or switched components and bring the board up and all that. And they really learn a lot through that process. And don't tell anyone, but it's a secret recruiting technique too, because we get to see all these students and see, what their capabilities are. So several of the people that we have on our staff now are people that we got through that. Ed is, Haley is, Phil is, and Kenneth is. All four of those people were people that we had that we mentored through as students.
Oh, I wanted to go through the Haley one. That would have been fun to watch.
Yeah, she was really fun. She had she's really great. She doesn't mind being wrong about anything. So I'd be like, well, what are you going to do about this problem? And she'd get up on the whiteboard and go, oh, I'm going to do this and this and this and this and this and this. And it'd be like, well, but what about this? And she's not timid about that at all. Really good student. And
she is an absolute brilliant mathematician, right? I mean, she wrote this paper, and I lost it after her name.
I did too. Yeah, we had to snatch her away from grad school.
And Steve was kind enough to Steve and Matt took me on a road trip when I was down there last year, and we went over to which university was it? Texas?
Texas State is where a lot of these kids are from. Yeah.
Yeah, and I was fortunate to watch Steve with this group, and I really enjoyed it. And then what blew Steve away out of the moment was this guy had integrated Slack to the repeater controller. It was great.
Oh yes, that was so funny. Yeah, I still talk to that guy. He's at A&M actually.
Yeah.
And so he still converses with me, and I'm waiting for him to graduate so we can talk to him.
Yeah, I think you offered him a job on the spot actually. When are you done? It's like, but into Flux's credit,
you're standing there going, he's serious. And, he's really serious.
Yeah, it was mad. I go, he's Anyway, well, Steve, those are great, and I just love being here and working with you and Ed and everybody, and even some of the new guys. We've got some amazing new people that fortunately, actually, Zoom has allowed us to get to know them a little better because we meet on Fridays on a virtual happy hour, and that's been an amazing event. If you've ever been in a company working in a remote employee, you would miss out on the trip to the bar or whatever for chicken wings or something, or even the lunches. And it's really, I think, brought the company a lot closer together. So even if and when we get back to whatever normal is, gotta hope these carry on because I've really enjoyed them. And I'm thanks for letting my boss drag you out of your busy day. And
no problem. It's fun.
And JP, any other questions for you?
No, I think we're fine. I learned a lot. I didn't know all those things.
No, and you've only been here since what? January, right?
Yeah, so, and March actually, right when the.
Oh, you never even made it in the office.
Exactly, I was going to mention that. I've been there 4 times, I guess. That was it.
You've done a great job. We've enjoyed having you on board, JP. So,
thank you, Steve.
Sorry, we can't give you an office. You just got to work it.
Checks on the mail.
Yeah.
Thank you.
All right. Well, ladies and gentlemen, thank you for your time. You can, as usual, watch this on YouTube at a later date, and I'll keep an eye on the chat for any questions and try to answer them. You can always email us at info@flexradio.com if you have any questions, and if you want to drill in a little bit and want a sales question.
I wanted to mention that my first boss, when I was 17 years old, he's watching us. 17 years old. Can you believe that? Long time ago.
Well, you did pay us to be nice about you.
Yeah.
Or you can email sales@flexradio.com for pre-sales questions. And perfect. All right. Thanks very much. And 73, everybody.
73s. Good DX.